So the point in the discussion yesterday was about what should be there inside the queue structure. So we have done this type definition. We said we require two ends or two pointers. One is front and other is rear. Mm, so let me draw the linked list over here, and let's argue that which end should be front and which end should be rear. So let's say this is the starting node, and then I can just replicate 3 or 4 times. Let's connect them together. So this is one. So this is the linked list. The point I was making yesterday was, irrespective of where you put your front or rear, we may have to traverse the whole linked list for the other operation, whichever I want to do at the last. So for example, if this is my front, I will delete from here, but I may have to traverse the whole linked list and then to do the insert operation at the end. On the other hand, if this is the rear, then in that case for delete, basically I need to traverse the whole linked list up to this point to delete the node, the last node, or the node at the last, at the other end. What is being missed out in this assumption? What is being missed out in this assumption is that I am having 2 pointers now. One is front and other is rear. Okay, so what we are discussing is not just having a single pointer, which is the list pointer, which is pointing to the first node over here. But we are discussing that I will keep 2 pointers. Even the last node will be pointed to, and I will give a name to that. Only issue is whether the first node should be front and last one is rear, or first one is rear and so whether the first one is front and last one is rear, whether the first one is rear and the last one is front. Okay, that is the only point of contention now. So the argument was that one of the two operations, which is at the end, would have become order of n if I had taken only single pointer at the start actually. But now that I have a second pointer at the end, whether irrespective of whether I call it as front or rear, now let me pose this question again, which I was asking yesterday, that now under this situation, what do you think basically that which end should be front, which end should be rear, and why? There is no top. Okay, Pulkit. So top at rear, what does it mean? I mean, we are talking about Q. Okay, so we have just front and rear. So Hassan says we always insert at start, and then first one will be rear and the last one will be front. Okay, so front at initial node and rear at last node. So Darshan has another idea. So we have multiple answers coming in. Okay, so you need to weigh these two options against each other. Okay, so one more thing basically. So yeah, so front at the initial node, which means rear at the last node. There have been a couple of suggestions that rear should be at the first node, which is like a top, I mean, where we insert, and then the front is at the last node where we delete. What do you think? Think closely. Why this question is being asked? For that, you have to worry, rather, you have to wonder that what if the last pointer was not there? If I had only the starting point, then in that case, I would say that actually does not matter, because one operation I can do very fast, which is at the start of the linked list, and last operation anyway requires the traversal of the linked list in either of the case. But now that last node can also be pointed to by a pointer, now the question is more pertinent, that now can I do something better? Yeah. Now, what does it mean? So, as far as the insertion is concerned, it can be done pretty fast because new node can be inserted at the start. So, insert at start is an order of one operation. But for delete, if I want to delete this last node, now from the diagram you can imagine that not only so I directly have a pointer to this last node, which I'm calling as front actually. Little bit misnomer in the sense that front I'm putting at the last node, but let's accept it. And I just by doing free of front. What is the problem? If I do free of front, that the link, okay, node over here, and I can just make sure that this rare I already have. So I can just make sure that this link basically from rare is to the new node now. And then this last node, I can set its next pointer to null. And then I can declare that now the last node is the rare node actually, rather than this. So if you see, the operations I am doing are over here. There is no traversal of the linked list which is involved. It is after this last node. No traversal of the linked list is involved. And because of that, the insertion which is at the rear would also become order of one operation, because it will also become efficient, because you don't have to traverse the linked list. Okay, and that is the reason, even if we have choice, and by the way, from functionality perspective, does not matter. In the last I manage it, I will still get the queue. But now I have an implementation where both insert as well as delete operations are ordered. And that's why I would choose my starting node as the front node and the last node as the rear node. So this is the justification. Okay, and this is how we need to think. It's not only about just declaring that initial node is the front or rear or whatever, but we need to worry about what are the implications of this